children, how are you today? I hope you are fine wherever you are. I am Miss Sankita, your mathematics teacher. I am from Sekolah Menengah Kebangsaan Raja Ali, which is located in Kuala Lumpur. Before we continue with our lesson, do you have your notebook and pen with you? If you already have them with you, then let's get started. Today, we will be discussing about polygon, particularly the topic on triangles. So, are you ready for the lesson? By the end of today's lesson, you should be able to first, describe the properties of a triangle. Next, you are able to determine the interior angle and exterior angle of a triangle. Finally, you are able to solve problems. Let's start the lesson with an activity. I have 3 sticks in my hand. Now, I would connect each end of the sticks to form a shape. Aha! I have got a shape. So children, what is the name of this shape? Yes, very good. It is a triangle. Can a triangle be considered as a polygon? If you answer yes, then why is it so? First, let's look at the definition of a polygon. A polygon is a closed shape and each side are made of straight lines. So, is this shape a polygon? I see straight lines and it is a closed shape. So, this is a polygon. Now, let's find out more about triangles, shall we? Triangles can be classified based on their properties. In this chapter, you will be able to categorize the triangles based on the properties of their sides and angles. Firstly, we will look at triangles based on the properties of their sides. This triangle is called an equilateral triangle. Why is it called an equilateral triangle? Let's look at the axis of symmetry of the triangle. Before that, I would like to ask you a question. What is axis of symmetry? Aha! Bravo! Axis of symmetry means the line that divides a shape into 2 equal shapes. For example, take a look at this equilateral triangle. When it is folded in half, the same shapes are formed on both sides. The folded line is called an axis of symmetry. How many axes of symmetry do you think this triangle has? Indeed, there are 3 axes of symmetry. Okay then, how about the angles of the triangle? Let's measure them, shall we? I am going to place my protractor here. As we can see, the angle measures 60 degrees. What about the other angles? As we can see here, each angle is 60 degrees. Make sure the protractor is aligned properly so that you get an accurate measurement. Hence, we can conclude that each angle in this triangle is 60 degrees. Here is a table that summarizes the information. As you can see, the number of axes of symmetry is 3 and all the sides of the triangle are the same, which means each angle is 60 degrees. Hence, this is an equilateral triangle. Moving on, we have the isosceles triangle. What are the properties of this triangle? As you can see, I have an isosceles triangle. If we fold an isosceles triangle, how many axes of symmetry do we get? Very good! 1x of symmetry. What are other properties that describes this triangle? Two of the sides have the same length. This also means the two base angles are of the same size. Base angle? What does that mean? This is called base angle. I mentioned that the base angles are the same. How can I prove it? Let's explore together, shall we? I am going to use a protractor to measure these two angles. First, I am going to label the angles as A and B. When I measure angle A, it is 40 degrees. Will it be the same for angle B? Aha! Angle B is also 40 degrees. Isn't it amazing? Both the base angles, which are angle A and B, are the same. Remember, not every isosceles triangle looks like mine. There might be different types of isosceles triangles. Here are some examples of isosceles triangle. Notice that they look identical. What makes them an isosceles triangle? Correct! Two of the sides have the same length. The two base angles are of the same size. Lastly, the scalene triangle. Children, what is a scalene triangle? Can you see all the sides of the triangle are not the same? I am going to try to fold the triangle now. Oops! I'm not getting any excess of symmetry. As a conclusion, scalene triangle does not have any excess of symmetry. Furthermore, all the sides are of different length and all the interior angles are of different sizes. Can you make your own scalene triangle based on their properties? Let me show you an example of scalene triangle that I have. Next, we will be learning about triangles based on their angle properties. First off is the acute angled triangle. If you realize, each of the angle in this triangle, which is the interior angle, is an acute angle. You might ask me, Teacher, what is an acute angle? An acute angle is any angle between 0 degree to 90 degree. Let us measure all the angles in this triangle. We have angle A, angle B, and angle C. I am going to measure angle A using a protractor. Angle A measures 45 degrees. On the other hand, angle B measures 55 degrees. How about angle C? I am placing my protractor at angle C. Angle C measures 80 degrees. It is proven that each angle measures between 0 degree to 90 degree. So, this is an acute angled triangle. Moving on, we have the obtuse angled triangle, where one of the interior angles is an obtuse angle. Do you know what is an obtuse angle? Yes, indeed! An obtuse angle is any angle between 90 degree to 180 degree. Here, I have a triangle. Let us explore the angles in this triangle. I am going to measure each of the angle of this triangle. What tool do I use to measure the angles? Of course, a protractor. I am going to place the protractors on each angle and measure them. I am going to label the angle as I measure them. As you can see, one of the angles is measured 120 degrees. The other two angles are acute angles. So, this is an obtuse angled triangle. Finally, we have the right-angled triangle. This is a rather special triangle because one of the interior angles is a right angle. You may ask, what is a right angle, teacher? Simple! A right angle is an angle that measures at 90 degrees. Children, we have learned the different types of triangles. Before we move to the next part of the lesson, let's play a quiz. I am going to show you pictures of triangles. You are going to tell me the names of the triangles based on their properties. Are you ready? First off, what is the name of this triangle? Very good! It is a right-angled triangle. What makes this a right-angled triangle? Of course, one of the angle is labeled as 90 degrees. Good! 1 point for you. Next, what is the name of this triangle? Observe the angles in this triangle. Yes, it is an acute angled triangle. Each angle in this triangle is an acute angle. Another point for you. Moving on, observe this triangle. This triangle looks very similar to a triangle that I demonstrated. What is the name of this triangle? Bravo! This is an isosceles triangle. I have an extra question for you. Why is this triangle an isosceles triangle? Wow, you are amazing! The base angles are the same and also the side lengths are the same. If you answered both my questions correctly, then I will give you 2 points. So, are you ready for the last question? I will give you 2 points if you can tell me the name of this triangle. Was your answer equilateral triangle? Then 2 points for you. As you can see, all the sides are of the same length. The small line labeled on each sides are the same, which indicates all the sides are of the same length. I hope you answered all the questions correctly. If you did not, stop here, rewind back, and learn this topic again. Make sure the next time you answer all the questions correctly, okay? Shall we move on? In the next part of this lesson, we will look into the interior angles and exterior angles of a triangle. An interior angle is an angle inside the polygon. This is a triangle. I have labeled the angles inside the triangle. All the angles are called the interior angle because the angles are inside the triangle. As you can see here, I have extended the line outside one of the angles of the triangle. Observe this angle. This angle is outside the triangle. Thus, this is called an exterior angle. Now, we are going to see the relationship between the interior and exterior angles. But first, let's look at this diagram. I have labeled each angle in this triangle as A, B, and C. Our motive is to find the sum of all these 3 angles. By the way, the word sum means I have to add up all the angles. I have the same triangle that I used earlier. I am going to cut each of the angle out like this. Next, I am going to arrange all the angles to form a line like this. Oh my! This is a straight line. What is the angle on a straight line? Absolutely! It is 180 degrees. So, when we add up all the angles, we can form a straight line, which is 180 degrees. Hence, the sum of the interior angles of the triangle, which is A plus B plus C equals to 180 degrees. This applies to all triangles. Before I continue to the next part of this topic, let us look at a question. Perhaps this question would give you a better idea about the sum of the interior angles of a triangle. In this question, you are required to find the value of angle P. How can we answer this question? Here's a tip for you. Use the sum of the interior angles that we just learned. Therefore, 45 degrees plus 120 degrees plus P equals to 180 degrees. Next, add up 45 degrees and 120 degrees to get 165 degrees. To find P, we will minus 165 degrees from 180 degrees. And the answer for P will be 15 degrees. Did you get the same answer as mine? If you do, then you are ready for the next subtopic. Next, we will be looking at the relationship between the interior angle, labeled as C, and the exterior angle, which is labeled as D. D is called the adjacent exterior angle. Adjacent angle means the angle next to a particular angle. It can be said that when we sum up the angle C and the angle D, we will get 180 degrees. Do you know why? Yes, they form a straight line. I am sure you have learned the sum of the angles on a straight line in a previous chapter, which is lines and angle. So, C plus D equals to 180 degrees. So far, so good? Finally, we have this triangle. There are two interior angles which are opposite to the exterior angle. The sum of the two opposite interior angles is equal to the exterior angle. In this case, A plus B equals to D. Children, as of now, we have finished learning all about triangles, starting from the type of triangles based on their properties of sides and properties of angles. Then, you also learned about the interior and exterior angles of a triangle. Now, I am going to give you some questions that puts all this knowledge together. If you need some time to look back at your notes, pause this video and do some revision before attempting the questions that I'm about to give you. If you are ready, let's start with the first question. Look at this diagram. What type of triangle is this? This triangle has two acute angles. Is this an acute angled triangle? Firstly, you need to find the unlabeled angle. I am going to use the sum of the interior angle to do so. Here, I am going to add 30 degrees to 60 degrees to get 90 degrees. Then I am going to subtract 90 degrees from 180 degrees. So, my remaining angle is 90 degrees. Aha! This looks like a right-angled triangle. Thumbs up if you answered correctly. How about this triangle? What should we do first? Of course, we need to find the unlabeled angle to determine what kind of triangle is this. I am labeling the angle as B. As you can see, I added B to 125 degrees and 20 degrees. This equals to 180 degrees. Then, I subtract 180 degrees with 145 degrees. Finally, the answer for angle B is 35 degrees. I can see two acute angles here, which is 35 degrees and 20 degrees. I also have an obtuse angle, which is 125 degrees. Hence, this is an obtuse angle triangle. Here's a star for you if you got this right. Next, look at this diagram. Find the value of M in the following diagram. As you can see, M is an exterior angle. And from what we have learned previously, the sum on the opposite interior angle equals to the exterior angle. Thus, to find M, add up 60 degrees and 75 degrees. You will get 135 degrees. There's another way to solve this problem. First is to find X, which is the interior angle of the triangle. Using the formula, we can write 60 degrees plus 75 degrees plus X equals to 180 degrees. Solve for X and the answer will be 45 degrees. Finally, to find M, simply minus 45 degrees from 180 degrees. Because it's a straight line. Your answer will be the same as the first method, which is 135 degrees. Can you follow? Good. Moving on. Let's look at another question. Find the value of X and Y in the following diagram. We will first find the value of X. I will highlight the triangle that has the value of X as follows. Can you see that this is an isosceles triangle? Why? There are two small straight lines that indicate that the sides are of the same length. Hence, the value of X at point P is the same as point S. So, 68 degrees plus 2x equals to 180 degrees. 2x equals to 180 degrees minus 68 degrees. To find x, we divide the answer 112 with 2. Finally, the answer for x is 56 degrees. Next, we need to find the value of y. Do you have any idea? Aha! I got it. Let's look at the bigger triangle. Notice the angle at point Q. It is 68 degrees plus y. Now, use the properties of sum of the interior angles to find the answer. 68 degrees plus y plus 56 plus 24 equals 180 degrees. Then 148 plus y equals 180 degrees. And finally, the answer for y is 32 degrees. Very good. Children, did you answer all the questions correctly? Now let's put our thinking hats. What did we learn today? You are now able to find the relationship between polygon and triangles. Then, you studied the different types of triangles. We also learned about the interior angle and exterior angle of a triangle and their relationship. Finally, the most important concept is the sum of the interior angles of a triangle, which is 180 degrees. So children, I hope you enjoyed today's lesson. Till I see you the next time. Goodbye from me.